Welcome to another session of Industrial Classroom. In this video, we would learn about the gear trains. See, these are mostly used in the industries, we know, in everything starting from your watches. Okay, so see this picture. Here you can see this is a gear number 1, this is gear number 2, this is gear number 3, this is the fourth gear, and here you can see this is the fifth gear. Here you can see these are a combination of gears engaged with each other to provide some motion, to provide some a change in direction, or there might be some torque change associated with it. Okay, or for larger distance, to cover a longer distance, we are using this. So what are these gear trains? Whenever we find the um, combination of gears to provide some required motion or to provide some required power, this is called gear train. Let us move on to the definition. A gear train is a combination of two or more gears arranged in a sequence to transmit motion and power from one step to another while modifying speed, torque, or direction. Remember the things which we have learned earlier. We learned that N1 T1 is equal to N2 T2. We learned it, right? So whenever we go to change the speed, it comes in this way. So why are these gear trains used if we know that to achieve a large reduction or a large speed reduction or increase? Remember the formula, N2 by N1 is equal to T1 by T2. This is the formula. Okay. So with a single gear, your speed reduction gets limit. You have to make this a very larger one. For example, if you want 200 RPM and here you need 3000 RPM. Okay, so you imagine that this must be extremely small and this must be extremely large. So why not make some gears in such an arrangement that the why not combine these gears in such an arrangement so that with limited reduction in size we get a higher reduction, because in this we know that whenever we are doing like this N2 by N1, or we always get, or we you say that N4 by N1 is equal to T1 by T4. So we will learn this in the combination chains. When you will study it, you will see that whenever we need a high reduction in or a high increase in the RPM or speed or the torque transmission, then we will see that with a single gear it is very impractical to achieve, because you would require a very larger dia gear or a very smaller dia gear, so which is very impractical. Now to change the direction of rotation, see, whenever, let me just erase what we have made here. To provide a change in direction, see, this is a pinion, this is a gear. So we know that this is rotating in clockwise, and this would rotate in anti-clockwise direction. If one rotates in clockwise, one rotates in anti-clockwise, if these are engaged. But how to change this direction to same? What I will do, that I will engage an idler gear here. So this rotates in clockwise direction, this rotates in anti-clockwise, and finally this will rotate in clockwise direction. So a change in direction is a change of direction of rotation is provided. Then transmit motion across large distances. For larger distances, we have studied here that to transmit some motion from this gear to this gear, a larger distances, a gear train is used. Next, to provide high torque multiplication. Okay, so what are the types of gear trains? Generally, we learn about 4 types of gear trains: the simple gear train, compound gear train, reverted gear train, and epicyclic gear train. There are some of the differences. Let us study this. In a simple gear train, each shaft carries only one gear. See this example, the image of this provided here. You can see that each shaft has only a single gear, and intermediate gears are called idler gears. For example, when I want to transmit motion from 1 to 4, okay, for example, when I need to transmit motion from 1 to 4, then these are one is this is the what we can say, this is the gear and this is the pinion. Okay, so now what are these called? These are the intermediate gears or the idler gears. Okay, Idlers do not affect the speed ratio, they only change the direction. Remember, we have just studied here that they do not change, they do not affect the speed ratio, but only help in changing the direction. So these are used in basic machine drives, printing machines, mechanical toys, hand mixtures. There are limited applications and because these are the simple type of gear, many mechanical toys use these gears. Now, what is the velocity ratio? If you know about the formula, then speed of the driver by speed of the driven is equal to n1 by n2 is equal to t2 by t1. The formula we learned here. Okay, n1 by n2 is equal to t2 by t1. So what is t2? T2 is equal to number of teeth in the second gear. Okay, and t1 is the number of teeth in the first gear. n1 is the number of the RPM of the speed of the driven gear. N2 is the speed of the n1 is the driver gear speed, and n2 is the speed of driven gear. So what are the advantages? First advantage is very simple design, very easier to maintain and low cost. Okay, but there are some disadvantages. Remember that these are not suitable for large speed changes. Whenever we require to change the speed, for example, the speed which we discussed here from 200 RPM or from 1000 RPM to, let us consider, from 200 RPM to 3000 RPM, there is a very high change in speed. With a single gear, it is not possible, and it requires more spaces for larger ratios changes. Okay, since change is done in only one single stages, so the change requires a very larger space. Now this is the compound gears. Here you can see what we had in simple gear is one gear to each shaft. Here there are three shafts. So one is the driven gear. Then in the second shaft you can see there are two gears. Okay, so first this teeth will move, this will engage with this one, the same RPM will be transmitted to this smaller one, and this will again further move this third one. Okay, so whenever at least one shaft carries two or more gears rigidly fixed together, then it is called a compound gear train. So what is that? Whenever there is a shaft which carries two or more gears rigidly fixed together, we call it compound gear train, right? So when are these used? These are used when there is a requirement of large speed reduction is required in a limited space. So your space is very limited within this space, but if you are provided with single stages gear, then you need to provide so many gears. But in compound gear trains, whenever we are engaging it, what we are doing is we are maintaining the shaft, we are maintaining the speed of the higher gear and the smaller gear and the bigger gear, which are rotating at a single speed. Okay, here you can see that this gear, the shaft has a single fixed RPM, and both the gears will rotate with the same RPM. Okay, because this is integrated with these are fixed with a single shaft. So these are used in every industry, you can say. Speed reduction in factories, in most of the gearboxes, in automotive transmissions, washing machines, electric screwdrivers, right? So here you can see that if the RPM of this is N1 and RPM of this is N2, the third gear is N3 and the fourth gear is N4, we know that N2 RPM is equal to N4. To take out the velocity ratio, we know that N1 by N2, okay, N1 by N2 is equal to T2 by T1. Also we know that N3 by N4 is equal to T4 by T3. This is some example. Let me show you how we are deriving this velocity ratio. Now we are multiplying this. Okay, N1 by N2 into N3 by N4 is equal to T2 by T1 into T4 by T3. Here we know that N2 is equal to N3, since they are rotating it with the same shaft. So speed of the second gear will be same as the speed of the third gear. So here this will cancel out, and we will get this final velocity ratio. N1 by N4 is equal to T2 by T1 into T4 by T3. So the velocity ratio will be equal to the teeth of the driven gear divided by the teeth of the driver gear. So these are the driven gears, you can say. T2 is being driven and N4 this T4 is being driven, and T1 is driving T2, and T3 is driving T4. So this is the thing. Now, what are the advantages? We see that there is a high large speed ratios, okay, possible, and the system is also compact since most of the gears are engaged in with each other in a single shaft. Now, the disadvantage is that it is more complex and it requires higher maintenance. The alignment must also be precise. Now, let us move to the next one, which is the reverted gear train. See, this is the reverted gear train. Here you notice that there is a single axis. The other axis is also parallel with the same one. Okay. So the axis of the driven gear and the gear which is being driven, or the driver gear and the driven gear, the axis is same. These you can see are linked with same shaft, but here these are different shafts, but they are coaxial, right? So this is a specific type of compound gear train where input and output shafts are coaxial, meaning they lie on the same line. Imagine your watch. Here you have timer. Here you have the watch, the hands or the arms. You can say the one is the ticking 60 seconds, and one is the minute arm, and one is the hour arm. So how are they rotating in the same axis? This is due to the possibility of this type of reverted gear, in which thing this is the larger tire, so its RPM will be less. Remember, it is the hour one. Suppose so the hour one is driving the other gear. Okay, this arm. This is the hour one. Now the second one is within it. Okay, it is the minutes one. The hour one, the minutes one. It is of larger, it is of smaller dia. You can see then its speed, if dia is equal to small, then RPM will be high. Okay, so you can see this is the arrangement. So they are starting from the same axis, and they starting from the same axis, and but their speed is different. See, whenever we need to keep input and output aligned while changing the speed, we use the reverted gear train, and to maintain a compact design where the power enters and exits the system along the same axis. Okay, along the same axis there is input as well as there is the output. Now, for example, these are used in automotive manual transmissions, analog wall clocks, wristwatches. What are the advantages? They are compact, aligned design, good for enclosed system and smooth operation. But there are severe disadvantages like design constraints, like gear sizes must satisfy the conditions because we need same axis. So the sizes must satisfy the condition. Then there is less flexibility in layout and costlier than simple gears. Now here you can see this is the epicyclic or the planetary gear train. Here you need to know that here see I am just showing you an image of this. Understand, this is the outside gear which is called as the ring gear, right? In the center, imagine a solar system. So this is the sun in the middle, and there are planets revolving around the sun. So remember, the center is the sun. So this is my sun here. This is the center. Now the planets are revolving around it, around the sun. So these all three are planet here, and the frame holding the planet here is called the carrier or the planetary carrier, or simply we call it as the carrier. Now outside the carrier there is a ring, okay, where the planets also mess with each other. This is the ring here, right? So let us come to the animated image. See, this is the animated image. Here at least one gear axis moves another around another gear. See, what is the component? Sun gear, planet gear, ring gear, carrier. We have learned this. This is extremely compact, but remember that there is very high torque and multiple speed ratios. Why? Because there are planetary gears, three planetary gears. So torque transmission will be through these three teeth, the teeth of three gears, okay, or the three planets. From a single source, you are getting torque transmission to three planet gears. So their contact area will be much larger, and therefore a very high torque can be transmitted. Multiple speed ratios, yes, the speed ratio will be multiple. There are multiple gears, the ring gear, the planet gear, the sun gear. Okay, so where are these used? These are used for automatic car transmissions, in the differential systems, in robotics, heavy machinery gear systems. You can see it in industries, in the BLT and stackers. Okay, in wagon tipplers, you will see this. Now then, in the wind turbines, in bicycle gear hubs, in electric drills. Now what are the advantages? High power transmission in very compact size. Okay, you learned that in a very small space, it will provide high power transmission. Then there will be multiple speed ratio and smooth operation. Disadvantages, see, you know the complexity here. So much expensive and complex design, and it is very difficult to maintain. So here you can see that the velocity ratio in case of epicyclic gear is termed as ns, or the rpm of the sun gear, and the rpm of the uh, arm or the planet gear. Then nr is the ring gear minus planet gear. So this is the formula which you need to remember. And in case the arm is fixed, remember, if this arm is fixed, here you see that whenever there are three options here. First, which one is running? So if the sun gear is running, then we think the ring gear is fixed, because all three cannot run, right? All three cannot rotate in all directions. So if the sun is running, you can say the planets are running with it, but the ring gear is fixed. This is the image where the ring gear is fixed. Now we can also fix this sun gear. If we fix the sun gear, we can see that the ring gear will rotate, and around with the planets will also rotate. But these will rotate around this sun gear. Okay, the sun gear can be made fixed. So it depends what you are fixing. You can also fix this arm. Whenever you are fixing this arm, the sun gear will rotate, and around with the ring gear will also rotate. So whenever you have a fixed arm, you can say that the rpm of the sun gear divided by the rpm of the ring gear is equal to negative of the rpm of the number of teeth of the ring gear to the number of teeth of the sun gear. So we have learned this, n2 by n1 is equal to t1 by t2. Okay, so this is the same formula wherever we are replacing 2 with the sun gear, 1 with the ring gear. And here you remember that this minus sign is to provide the opposite direction. Now remember, in differential gear trains, this allows two outputs to rotate at different speed. Okay, differential gear train allows two outputs to rotate at different speed to enable speed variation between output. What are the differential gear trains? First, we need to remember these are the special epicyclic type. See, this is the image of a differential gear train. Okay, so here what are the differences? You see that here my speed is 1.5, but it is rotating. Now see this speed, see the changes. Here this has stopped. Now this is stopped. This is stopped. You see this video a little bit. Next we will learn. Now see, this is stopped, but this is rotating. The first gear is rotating at 1.5, second is rotating at 0.5. Both are rotating at same RPM. See the changes. That without affecting the one. Where are these used? Let me show you a question. Whenever you are seeing a four-wheeler or a big truck taking a turn, right? You see that both wheels cannot move with the same speed, because whenever they are taking a turn, one needs to be stopped, one needs to move backward, one needs to move forward. Okay, whenever they are moving it in a straight line, they can move, they can go. But for turning, imagine that for turning, one needs to stop and other needs to cover a greater distance. Okay, for example, see this. This is my path. Now you can see that this radius of curvature is very less. So here you require a slow RPM whenever this wheel needs to move this, and then again you will go straight. Okay, the rear wheel or the left side wheel will need to cover this distance, but this will need to cover a very small distance. Then again they will go to the straight path and they will go along. So these are used in vehicles. Okay, automatic automobile differentials in vehicles, remote control cars. So these here you will get two outputs to rotate at different speed, and so you will get speed variation between the outputs. So what are the advantages? Smooth motion in turning applications, prevent slipping and wear, and essential for vehicles. Remember, these are very essential. Disadvantages are complex and costly, requires lubrication, power loss in some conditions. But considering the advantages, we can ignore these disadvantages because these are limited. Now for the differential gears, we need to know that n1 plus n2 is equal to 2na, where n1 and n2 are the speed of two output shafts. Okay, so this is the output one, this is the output. So this is the arm here. Here you can see this is the arm. This is the arm na, this is n1, and this is n2, right? So n1 plus n2 is equal to na, 2na, and difference in speed is equal to n1 minus n2. So I believe that you have understood all these. Now let us learn that input comes to the carrier, output, this is the carrier here. Input comes to the carrier, then the output goes to the two shafts or the left and right wheels. If both output face same resistance, then they will move with same speed. If one side resists more, then other rotates faster. Now let us see the difference between the planetary gear and the differential gear. See the purpose. The purpose of planetary gear is for speed and torque variation. But for differential gears, the purpose is different, to generate different output speed. Then in case of planetary gear, there is usually one output, but in differential gear, we can see there are two outputs. The input is any member, like the sun, ring, arm we have learnt, but here the input is carrier. The fixed part is generally one part. We can fix the sun, ring or arm, but here there is no fixed gear. The motion here we get controlled gear ratio, but here we will get self-adjusting speed. And the applications, gearbox and machines. In differential gears, we use in cars and vehicles. Now let us see, this is a small tabular chart. You can just pause and go through it. We will not be discussing this. Remember, what are these questions? What is the function of idler gear? The idler gear is to change on a direction, no speed ratio change, only change the direction. Why use compound gear trains? To achieve large velocity ratio in compact space. What are the difference between simple and compound? We learned the differences in the shaft. Where are epicyclic gear trains used? Mainly in watches and your clocks, right? Sorry, we are talking about the epicyclic. So here these are used in automatic transmission, robotics, differential. Reverted gear trans used in clocks. Why? Because input and output shafts must be on the same axis. So this is all for today. Stay tuned and subscribe to our channel. Okay, thank you all and have a good study time.